So we start question 1 with a sort of just a hypothesis test for a binomial. So we've got p is 0.25 or p is greater than. We're going at 5% and a sample of 10 is taken. So assuming h0, then x is a binomial, and we've got 10 things here and 0.25. So on my distributions calculation here, I'm going into binomial and I'm going from greater than, let's just start with 10, and we've got a 0.25 there. So the probability we're interested in is a 5% significance level. So I've got a 5% significance level. I'm going to put 0.05 in here, and it's going to give me something close to the answer. So the probability that x is greater than or equal to 5 is equal to 0.0781. Yes, of course, we should look at that and see. But that's too big. We want it to be 5%, so actually going to have to go to the next one. So we'll change this to a 6. And at this point here, we are now under the 5% we were looking for. So my critical value here is 6. Critical value equals 6. Critical region, the region is x is greater than or equal to 6. So value 6, region greater than or equal to 6. So there's nothing new there, but in part B, we're now looking at the error. Now the type 1 error, is the probability that x is greater than or equal to 6, given that h0 is true. So given that we were in this situation here, what's the probability that it's greater than or equal to 6? We've just done that. That is 0.0197. That is the probability of making that error. We built that into the test. But on a type 2 error, that is the probability of saying x is less than or equal to 5, given that h0 is false. Now, we don't know anything about this, and so they have to tell us. So they tell us in the question that it's later found out to be p is equal to 0.3. So in this case here, let's go back to our calculator here. In this case here, we now know that this p is 0.3, and we want to be less than or equal to 5. So we would have accepted h0 in all of those cases there, and that gives us 0.9526, or if I round it, 9527. So the probability of making a type 2 error in that situation is 0.9527.